we looked at how we generate the line of best fit. The process of fitting the best fit line is called the linear regression between the two variables. The criteria for the best fit line is that we minimize the sum of the squares of errors. Any other line we might choose will have a higher SSE than the best fit line, and for this reason the best fit line is called the least squares regression line. The line of best fit is only sketched within the domain of the data. Remember that it starts at the minimum x value and ends at the maximum x value for the corresponding estimated y values as y hats. It is important to sketch the scatter plot first. If the scatter plot indicates that there is some linear relationship between the variables, then it is reasonable to use the line of best fit to make predictions for y given some x value. The problem with making a prediction is that this x value must be within the sample data, which is the domain of the variable x. It is not necessarily true that it will provide a good and reliable prediction for x values outside of that domain. For example, if we wanted to use the line of best fit to estimate a final exam grade for a student who scored a 73 on the third test, we could use the linear regression line, the line of best fit, to plug in x equal to 73. So 4.8274 times 73 minus 173.51. And I will just use my Excel here. And notice here that we don't have a 73 as an x value, so I'm just going to add it here in the bottom. So let's say 73 for my x, and I will just copy the y hat equation here, and it will use the 73 as the x value and the same a and b's that I used. So here I have an estimated final exam grade of 178.9. So using the line of best fit, I can estimate that someone who scored 73 in exam 3 would obtain approximately a 179 in the final exam. Could I do that for an x that is equal to 30? So could I also have a reasonable estimation using the line of best fit for x equal to 30? Notice that 30 is way outside of the scope of the data. My data was about 65 was my lowest. So I had here 65 for my lowest, and 30 is all the way to the left this way. So could I do that estimation? So let's see if x is 30. Could I use the same process to estimate a final exam grade? So here it says that the final exam grade would be negative 28.7. Is that a reasonable estimation? If we are talking about a final exam grade, a negative grade does not make sense. So are the predictions reasonable? Well, the y hat for 30 is not reasonable, and that is because it is a negative score. Why is it unreasonable? It is unreasonable because the value of x is way outside and very far away from the scope of the data. This line was generated with x values between 65 and 75. It could do a reasonable prediction very close to that or within that data values. But so far away as 30, it does not apply anymore. It is not a valid model for data very far outside of the domain. The next thing we want to remember is how to interpret the slope and the y-intercept. The slope of the line describes how changes in the variables are related. It is important to interpret the slope of the line in the context of the situation represented by the data and write a sentence in English. And the y-intercept describes the theoretical initial conditions of an experiment. And again, it is important to be able to write a complete and correct sentence in English. Remember that we discussed the interpretation of the slope and the interpretation of the y-intercept when we introduced the line, and we said that the slope is that y changes a certain number of units for each 1 unit increase in x, and the y-intercept is that the y equals a certain number of units when x equals 0. So remember that template here and fill it out in this part of your notes, and then we will use that template to interpret the slope and the y-intercept for the line of best fit for the final exam grades based on the third exam grade. So the one thing that we have to be very careful here is that the equation is actually y hat equals to that. So when you are describing the y, you have to make sure you mention that it is an estimated value for the dependent variable, or that the value is estimated to change or to be equal to, something like that. So make sure you use the word estimated when you are describing y. So for the line of best fit for the final exam grades based on the third exam grade, our A was 4.8 and our B was negative 173.5. We don't really need these decimals. It doesn't make sense to describe a grade in accuracy of, say, a 10,000th or a 1,000th. So we will leave it at the accuracy of a 10th, at most 100 when we are talking about grades on tests. So to interpret the slope, we will say that the estimated final exam grade or the final exam grade is estimated to increase 4.8 points for every 1 point increase in the third exam score. Or in better English, we are estimating that the final exam grade of a student who has an additional extra point in the third exam as a grade will increase by 4.8 points. The final exam grade, right? Or the anticipated or the estimated final exam grade. And for the y-intercept, we will say that the estimated final exam grade is equal to negative 173.5 points if the third exam score is equal to 0 points. And again, this particular interpretation does not make any sense, but that is what this line indicates, that a student who scores 0 in the third exam will end up with a negative 173.5 in the final exam. 0 is way outside of the scope of the data.